Speed, time and distance proportionality is one of the most important topic in arithmetic. So we will be solving many questions from this topic. Every time a question appears on the screen, just pause the video, give it a try and then continue. So two friends start running on a straight path with speeds in the ratio 9:11. When they meet, it is found that the faster one has covered 24 meters more than the slower one. So we'll solve the first part first. Find the distance between them when they started running if they run towards each other. So this is the case. First person is running towards right, second is running towards left. They are running towards each other and ratio of speeds S1 is to S2 is 9:11. They will meet somewhere here on the left because speed of 2 is more than speed of 1. So they will meet here slightly towards the left of the center. Now if nothing is mentioned, we assume that they started running simultaneously, and when they meet, they both will have run for the same time. They both started simultaneously and they meet at the same time, so they both must have run for the same duration. Time here is constant for both, and this is a classic scenario of time being constant when two people start running simultaneously and they meet somewhere. As time is constant, speed will be directly proportional to distance. So d1 is to d2 will also be equal to 9:11. Okay, this distance is d1, this is d2. We have to find this complete distance. Okay, we have to find the distance between them. That would be d1 plus d2. Now on ratio scale, d2 distance is 2 more than d1. The difference between d1 and d2 is 2. But in actual, the distance faster guy covers more than the slower is 24 meters. So this 2 on ratio scale corresponds to 24 meters in actual value. That means the multiplying factor here is of 12. We have to find total distance. Total distance on ratio scale. Total distance on ratio scale is 9 plus 11, that is 20. 20 on ratio scale will correspond to 20 into the multiplying factor, that is 240 meter in actual. So total distance is 240 meters. Moving on to the second part of this question. Find the distance covered by the faster one if they run in the same direction. Okay. This is the first person running towards left and second person is also running towards left. Okay, they both are running in this direction. They cannot be running in this direction. This is not possible. They cannot run towards right because speed of second person is more than speed of first person. S1 is to S2 is 9:11. Okay, so if they are running towards right, first person will never be able to catch second person. Now again, as they leave simultaneously and meet somewhere, time is going to be constant, and time is constant, that means distance will be directly proportional to speeds. Distance covered by the faster one is 11 on ratio scale, right? And the difference between the distances covered by first guy and second guy on ratio scale is 2, which corresponds to 24 meter in actual. So the multiplying factor here is of 12, and we have to find distance covered by second guy. That would be 11 into the multiplying factor, 11 into 12, that is 132 meters. Okay, moving on to the next question. We have already solved this question in the first video, in the very first video. Here is an alternate solution to this problem. Varun goes to school at this speed and reaches 6 minutes late. So there is a case when Varun goes slow, reaches late. And in second case, Varun increases his speed and reaches 9 minutes earlier. So Varun goes fast and reaches early. So these are the two cases. Between home and school, the distance is constant. Distance d is constant. As distance is constant, we can say speed is going to be inversely proportional to time. Ratio of speeds S1 is to S2 is given as 10 is to 12, which can also be written as 5 is to 6. So if ratio of speeds is 5 is to 6 and time is inversely proportional to speed, T1 is to T2 will be 6 is to 5. It would be inverse of ratio of speeds. Now reaching 6 minutes late and reaching 9 minutes early. 6 minutes late means this is the time in clock when Varun reaches school. Okay. And 9 minutes early means this is the time in clock. So this difference between reaching 6 minutes late and 9 minutes early is 9 plus 6, 15 minutes. This difference is 15 minutes, which on ratio scale is of 1. 6 minus 5 is 1. So this difference in T1 and T2 is 1 on ratio scale, which corresponds to 15 minutes in actual value. So multiplying factor is of 15, and T1 when he goes slow, this time would be 6 into 15, that is 90 minutes. So when he goes slow, his speed is 10 km per hour and he takes 90 minutes. 90 minutes is 1.5 hour. 10 into 1.5 speed into time would be the distance D, that comes out to be 15 kilometers. So in the first case, our time was constant when two people were running towards each other or running in the same direction in order to meet at some point. In this case, distance is constant and the person covering the distance is changing its speed, and due to change in speed, the time is also changing. We'll solve a few more questions in the next video. Thank you.